Come back grade 10s to the edge. We identified that there are two types of waves, mainly a transverse wave and a longitudinal wave. So in the second part, we'll just go through what a transverse wave is. Right. But before we go through that, I just want to say with this topic, one thing that we need to know is we need to know how to define what waves are, specifically transverse and longitudinal waves. We also need to state some of the examples of these waves: water waves, sound waves, whatever that they may be. We need to know what are some of the examples of these waves, and we also will be required to identify them in case they tell us, oh, you have a water wave, you have a sound wave, what type of wave is that? We also need to know what are some of the characteristics of these waves. What are the things that describe these waves? There's something called compressions and rarefactions, there's amplitude, wavelengths, frequencies. So characteristics could be the amplitude, the wavelength, the frequency, the period, and the energy. So these are just some of the main, this is very important, some of the main points that will also help you with just going through this topic. You have to highlight, okay, do I know what a wave is? Do I know how to describe it? Do I know what are some of the characteristics of these waves? And do I also know the examples of each of these waves that we'll look at? So now let's go to what a transverse wave is. So a transverse wave is simply a type of wave whereby the particles vibrate at right angles along the medium relative to the motion of the wave. And one of the examples of this type of wave is a water wave. A very simple example that I can make is if you have a body of water, I don't know if you've seen this, and here you are there with your friends and there's a body of water there, and you just throw a stone. You've tend to notice that what happens is this water will basically start rippling in such a way. So you've basically generated what we call a transverse wave. And what this wave does is that it also carries energy, right? It transfers energy to the other particles, but then it basically has energy or transfers energy. And this is going to be very important when we're just looking at the characteristics of these waves. But basically, this is how we represent waves. So it's quite different from how we represented a pulse. So this is just how we represent our wave. And we can see that it's just like this disturbance along this medium that we have. And this is what we call our equilibrium position. And so we identified what an amplitude is when we were looking at pulses in the previous video. And we said that the amplitude is basically the distance from the maximum position, which is called R, to the maximum point. Or it also could be to the minimum point in the case of a wave. So that distance from there to the minimum point, and this maximum point we call the crest, and the minimum point of a wave we call a trough. And when we want to look at 2 points from here to there, 2 crests, this is what we call a wavelength, right? So basically a wavelength is the distance between 2 consecutive points that are in phase. So in this case we just identified 2 crests, and what in phase means is basically means that these points are in the same line or they're aligned, right? In phase, points are in line, and out of phase will be the opposite. Points are not in line. So this is just basically it, right? So another example that I can make is that if maybe, for example, you have a point here and let's say we have B here. So A and B are in phase, but let's say this should have called this let's just call this C. A and C are in phase, and this one we'll call B. A and B are out of phase. So we're gonna come back to this concept in depth because it's very important to know when points are in phase, when points are out of phase. But basically this is what it means. And another thing that we also need to describe is a cycle. So here I didn't draw it properly. So this and this wave goes like this. So from maximum to minimum, we can call this one cycle. And this will just be represented as seconds. And so one of the terms or one of the things that describe a wave is what we call period and the frequency. And the frequency is just basically the number of times it takes for a wave to complete a cycle. And this is represented as F. And as I said, that the period is just basically a cycle. So that's just basically the time it takes a wave to complete a cycle. So these are just some of the terms, and this is represented by T. And the way in which we link this is F is equals to 1 all over T. Yes, that's just one of the characteristics. That's just like some of the ways we describe waves. Another concept is speed, particularly wave speed. And the equation for wave speed is V is equals to the frequency times lambda, which is the wavelength, and its SI units are meters per second. And another variation of this, since we know what the equation of frequency is going to be 1 all over T times the frequency, if we're not given the frequency and we're just given the period. So this is just the wave speed. So it basically describes how fast the wave is traveling along the medium. So how fast the wave is traveling along the medium. And it's going to be an interesting, as we go down the road, we're going to see that for light, the speed will be described as this. This is what we call the speed of light. But in this case, most cases, we will have our variables. And last but not least is the energy of the wave. And the energy of the wave is basically, we said that a wave also transfers energy, or the particles carry energy in simpler ways. There is a definition for it. The wave basically does carry some energy with it. And so the equation for that is E is equals to HF, and this is what we call Planck's constant. And this will basically be for light waves. So this is just some of the characteristics. These are the characteristics of waves, and we, as I said, we are supposed to know how to identify the examples of these kinds of waves, and also just know how to define these characteristics by using equation.